Hello and welcome back to another episode of Math with Zone. Today we are going to be looking and determining if lines are parallel, perpendicular, or neither. And there's a few ways to do this. So we could look at it graphically. Let's say we had two lines and we're looking at them and they just never intersect. And we could look at it and we could see graphically that these are parallel. And we could compare the slopes if need be to figure out if in fact they are parallel. We could also look at them and let's say that one of them is going this way and the other one is going that way, and it is a perfect 90-degree angle, which normally you can't tell for sure if it's a perfect 90-degree angle, but that would be considered perpendicular. And then occasionally you'll be able to have one that is neither parallel or perpendicular, and that actually happens more often than not because most things in life actually are not straight and make 90-degree angles or perfectly side by side. Most things in life would be considered neither, where it's just they intersect. They don't make a 90-degree angle, and they are not considered perpendicular or parallel. So this would be considered neither. Neither parallel or perpendicular. It's just normal. So, if you're given the graph, you could visually kind of ascertain whether or not they are parallel, perpendicular, or neither. But if you're not given the graph, what if you're given perhaps just a set of points? How would we do it then? So, if you're given a set of points, what you would need to do is first figure out how to compare the slopes. So we need to figure out something called a negative reciprocal, which I call flip and switch. So if I have a slope that happens to be 4 over 5, the negative reciprocal, you would flip the fraction and switch the sign, and it would become negative 5 over 4. If this happens, if you flip and switch the sign, you flip the fraction and switch the sign from positive to negative or vice versa, then that would be considered perpendicular if the slopes do that. If the slopes are identical, let's say you had 4 over 7 and it became 4 over 7, if the slopes are exactly the same, then they would be parallel. If the slopes do anything other than being exactly the same or flipping and switching, then they would be considered neither. So let's say we had 12 over 5, and then over here we had 5 over 12. It flipped, but it did not switch the sign. They are both positive. This would be neither parallel or perpendicular. But you do need to be careful, because sometimes things simplify and it either makes it look like they're not perpendicular or makes it look like they're not parallel. For instance, if I gave you negative 5 and the other slope happened to be, I don't know, negative 20 over 4, well, negative 20 over 4 is still going to divide down and become negative 5. So this is still considered parallel. And the same thing can be said for perpendicular. Let's say you have 5 and the other slope was negative 1/5. Well, this is still considered perpendicular because this 5 is always technically over 1. And if we flip that, we end up with 1 over 5 and the negative would become in front. So what would that actually look like on paper? Well, on paper, it could be given to you in one of 3 formats, but really it's just one of 2. And that would be, they could give it to you as a set of coordinates. We could call them a set of coordinates A, B, 3, 1 would be A. And B, I am going to make 4, negative 8. And then we could have a set of coordinates called C and D, which I am going to make 4, 3, and D, I am going to make negative 5 comma 2. Now I want to know what is the relationship between AB and CD. I want to know if those lines right there are parallel, perpendicular, or neither. And the way we will do that is by finding the slope of each using our handy-dandy slope formula, y2 minus y1 over x2 minus x1. So we're going to plug both of these lines essentially into that. We want to plug in AB, and then we want to plug in CD, and then we want to compare the slopes. So x1, y1, x2, y2. We would have negative 8 minus 1, negative 8 minus 1, over 4 minus 3. Turns into negative 9 over 1, which you could simplify, but I choose not to with these problems right away at least. So that is the slope of AB. But we also have to find the slope of CD. So that would be 2 minus 3 from the y2 minus that first y value over negative 5 minus 4 for the x2 minus x1. And when we do that, we end up with negative 1. 2 minus 3 is negative 1. And negative 5 minus 4 is negative 9. Now, this looks awfully close to one another in some way, shape, or form. So we have to determine, are they parallel? And the answer to that one is actually easier. They're not parallel because one of them has 9 on top, the other one has 9 on the bottom. They're not going to be parallel. But are they perpendicular? Well, that's a little more difficult to understand. And what we have to do is realize negative divided by a negative actually makes it positive. So if we actually have a positive 1/9 here, now it's a little bit easier to see that, yes, in fact, these are flipped and switched versions of each other. 1 over 9 flipped, became 9 over 1, and it was positive, and now it became negative. So that would mean that these are, in fact, perpendicular, and we have confirmed that using the slope formula to compare the slopes. Now, sometimes it's not going to be given to you in a point format. It could be given to you in a equation of a line. So let's say we had this line right here. We'll call it line A, and this line right here, we'll call it line B. What if line B was, let's go with 4x minus 8y equals 2,148. And there's a reason why I chose 2,148, because we don't care about the y-intercepts to figure out if the slopes are parallel or perpendicular. We only care about the slopes. Okay? So the slope of line A, that one's really easy. The slope of line A is 2, or you could say 2 over 1. What is the slope of line B? Well, the slope of line B, we don't know yet. It's not 4. It's not negative 8. It's not 2,148 either. What we would have to do is solve for y. And you're going to solve for y by subtracting 4x. These are not like terms. They are not going to combine. You end up with negative 8y equals negative 4x plus 2,148. And then we have to divide everything by negative 8. Divide by negative 8. Divide by negative 8. Divide by negative 8. Cancels. Who cares? We don't care about the y-intercept right now. All we care about is the slope. And here is that wonderful slope, the negative 4 over negative 8. And we learned from just a minute ago in this video that negative divided by a negative becomes positive. Now these are looking like they're completely different, but 4 over 8 actually simplifies down to 1 over 2 because 4 goes into 4 one time and 4 goes into 8 two times. So now I have my slope of both of them. Are they parallel, perpendicular, or neither? Well, they're very close to each other. We had 2 over 1, and here we have 1 over 2, so they flipped. Did they switch the sign? No, they didn't. Both of these are positive, so We flipped the fraction, yes, 2 over 1 flipped, the 2 became on the bottom, the 1 became on the top, but we didn't switch the sign, and these are not identical. If they're not identical, they're not parallel. This is neither parallel or perpendicular.